Hello everyone. Let us continue our discussion about velocity time graph. In last video, what we have discussed that whenever the uniform velocity or constant velocity of 40 kilometer per hour, the car is traveling with this velocity, then the area under this velocity time graph or this rectangle ABCD will give us the magnitude of the displacement for the corresponding time T1 and T2 or for the time interval T2 minus T1. Here velocity was uniform or constant. In this case, velocity was increasing. Here you can see as time is increasing, velocity is increasing. But the change in the velocity for the time interval, the change in velocity for any time interval, we take time interval 1, time interval 2, for any time interval where the time interval magnitude we have kept same, dt and dt only. But if you calculate the slope of this line, how we will calculate the slope? Change in velocity divided by change in time. So dv by dt ratio throughout this journey, throughout on this line, if we calculate the slope, then that slope is constant, right? So here acceleration is constant. Velocity is, it is increasing, but the acceleration is constant here. That's why we will call this motion as uniformly accelerated motion. Here in this case, the velocity it is decreasing. Here it was increasing, here it is decreasing. But here if you calculate the slope of each this segment, then and if you calculate the change in velocity divided by time, dv by dt ratio for each segment, I will say the dv by dt ratio it is different. For this it is different, for this it is different, for this is different. It means acceleration for this time interval it is different, for this time interval it is different, for any if you take, then for any this segment or for this time interval also the ratio dv by dt is different. They are different from each other. They are not same at all, like here it happens. So because of that only, as the acceleration is different for different segments, we will call that accelerated motion as a non-uniform accelerated motion where velocity is decreasing. So now in this video, we will discuss where velocity is increasing and velocity is decreasing together. As you can see in this graph, velocity versus time graph, here on y-axis velocity, on x-axis time. From here to here, velocity it is increasing. Then from here to here, velocity is decreasing. Here again it is increasing. Again it is decreasing. There is increase, decrease, such kind of motions we are observing. And suppose for better understanding, if I give numbering to these lines 1, 2, 3, 4. If you observe carefully, line 1 and line 3 both have positive slopes. Line 2 and line 4 they have negative slopes. But even though the slope of the line 1 and 3 they are positive, but if you think of their magnitudes, if you calculate their magnitude, slope magnitude, then that slope magnitude is different. Similarly for line 2 and line 4, they have negative slope, but if you calculate the slope magnitude, that slope magnitude is different for 2 and it is different for 4. So I can say here it is accelerating, then it is retarding, then again it is accelerating, then again retarding. Such kind of motion where non-uniformity is there, such motion we will call as a non-uniformly accelerated motion. Here also this is non-uniformly accelerated only, but here only we are observing velocity decrease, but here velocity increase also there and velocity decrease also there. So examples of this uniform non-uniform motion is car traveling along a straight road. It increases or decreases its speed by unequal amount in equal interval of time. Suppose morning 10 a.m. I'm starting my journey. I've started my journey. Then 10 to 11, first 1 hour, I can increase my speed or I can decrease my speed. There will be some time rate. And from 11 to 12 for the next 1 hour, again I can increase my speed or I can decrease the car speed. But the rate I am saying, the rate of increase or decrease in first hour and rate of increase or decrease in next hour or second hour, they can be different from each other, right? Similarly, as an example, while traveling on the road, it's not that we every time increase the speed or every time we decrease the speed. how the road is, how the road, whether it is downward slope or upward slope, or whether it is flat road. Based on that, we will decide the car speed. Or if you are at a some traffic jam place, or somewhere at some toll plaza, then that point of time your car speed will be decided by the surroundings, right? How other cars are flowing, or other cars are moving in the traffic situation. Based on that, we will change the speed of the car, right? There the motion of the car is, I will say, non-uniformly accelerated. So this is in single short video we have discussed the when the velocity is constant, then how when the velocity is increasing, here velocity is decreasing, and here there is velocity is increase and velocity decrease. So in a single video only, all the velocity time graph for 1, 2, 3, 4 different cases we have studied, and this is very useful. This is very important concept. In coming videos, we will discuss more about this distance time graph and velocity time graph. Thank you.